So, let's start our lecture again. So, we have seen that this Rx, so we have proved this R x over Ix, Ix square brackets is isomorphic to R over Ix. So, from this, we conclude that suppose if R is an integral domain, or if this I is a prime ideal, if it's a prime ideal, if it's a prime ideal, then R over I is an integral domain that we already seen. Ideal is prime if and only if the quotient ring is an integral domain. And if this is an integral domain, then this one is also an integral domain that we already discussed. This one is an integral domain. Integral. So I is prime implies R over I is integral domain. That implies R over Ix is integral domain. Now, by this result, above isomorphism, we can say that Rx over Ix is an integral domain. Is an integral domain. Then by the same result, the quotient ring is integral domain if and only if the ideal is prime ideal. So from this we conclude that this ideal Ix is prime is prime. So we have seen that if I is a prime ideal, then Ix is also a prime ideal. Ix is also a prime ideal. Now we check the division algorithm in Fx, the ring of polynomials or field. We prove the following theorem actually. Let F be a field. Let F be a field. Let F be a field. The polynomial ring Fx is a Euclidean domain. Is a Euclidean. Specifically, we can say this. How it's Euclidean domain. Basically, if we have two polynomials, if we have polynomial is ax bx, ax and bx are two polynomials in fx, are two polynomials in fx, are two polynomials in fx. With bx non-zero, obviously. With bx non-zero, with bx a non-zero polynomial. That means all the coefficients of bx are not equal to 0. Then there are unique qx or x. Then there are unique two polynomials qx and rx, qx and rx in fx. Hmm? The same ring fx such that ax is equal to bx times qx plus rx, where rx is either 0, where rx is 0 or its degree. Its degree is less than degree of bx, or degree of rx is less than degree of bx. And we'll also see that degree is actually the that norm. Degree satisfies the properties of the norm. And n of any polynomial px equal to degree of px is a norm, is a norm on fx. एक्चुअली आपको नॉर्म मिलना चाहे fx पर जिसकी वही प्रॉपर्टीज होती है, सिमिलर प्रॉपर्टीज जो कि डिवीजन एल्गोरिथम की होती है। वो यहाँ वो जो नॉर्म यहाँ पर है दैट्स द डिग्री ऑफ px, क्योंकि यहाँ पर आपको फाइनली मिला डिग्री ऑफ rx। आपको क्या मिलना चाहिए एक्चुअली? नॉर्म ऑफ rx लेस देन नॉर्म ऑफ px। नॉर्म इज द डिग्री ऑफ px। So this is the statement of this theorem. Every fx is Euclidean domain. Specifically, can state it like this: if we have two polynomials ax, bx, if bx non-zero in fx, then we can find unique polynomials qx and rx in fx such that ax is bx times qx plus rx, with rx is either 0 or its degree, or you can say its norm is less than norm of x. Proof. If ax is 0, then there is nothing to prove, because in that case we can take qx and rx both equal to 0, because x is any polynomial, bx is non-zero. If this polynomial ax is 0, then we take, क्योंकि आपको qx and rx चाहिए ना, then we take those polynomials as, then we take qx is equal to rx is equal to 0. rx पर कंडीशन है that should be either 0 or its degree should be less than degree of bx, और यहाँ पर मैं rx 0 ले ही रहा हूँ, so we don't need to check the properties because it is 0 polynomial. और ये जो qx और rx को अगर आप 0 दोगे it will satisfy this equation. आपके पास इक्वेशन क्या होनी चाहिए? ax इक्वल टू मस्ट हैव दिस इक्वेशन, ax इक्वल टू bx टाइम्स qx प्लस और x, this equation. And by setting, if ax is 0 and by setting qx equal to 0, rx equal to 0, we have 0 equal to 0. So this equation is satisfied with rx is either 0 or degree of rx is less than degree of bx. So thus in this case we have nothing to prove. So therefore we assume that ax is not equal to 0. Therefore we assume that this ax is a non-zero polynomial. And its degree suppose, and degree of ax is supposed n. If it's non-zero polynomial, it has certain degree. Now to prove the result, we use induction on n to prove To prove the result, we use induction on M. Now we have a polynomial bx which is non-zero. It has also certain degree. Let's suppose that its degree is m. Let degree of bx, which is a non-zero polynomial, given non-zero polynomial, suppose that its degree is m. In case n is less than m, मतलब जिस पॉलिनोमियल से आप डिवाइड कर रहे हो उसकी डिग्री ax से ज्यादा, उस केस में भी रिजल्ट इज ट्रिवियल. तो इंडेक्शन हम उसी पर करेंगे अपने जहां पर n लेस और इक्वल टू m. ओके, सो इफ n is less than m, again result is straightforward. How? By taking, in that case, so what we do, we take qx equal to 0 and rx is equal to what? Rx equal to ax, because degree of rx is a and degree of bx is m. So in this case we take, see this, in this case we take this, we take the quotient as 0 and remainder जो है इसका rx that we take as x. क्योंकि रिमाइंडर पर सिर्फ एक ही कंडीशन है, इट शुड इधर बी 0 और इट्स डिग्री शुड बी लेस देन डिग्री ऑफ bx. और इस केस में जो हमने यहाँ पर ये आर एक्स को एक्स लिया है, यहाँ पर डिग्री ऑफ आर एक्स क्या होगा? इट सेम डिग्री ऑफ एक्स, बिकॉज आर एक्स इज सेम एक्स and the degree of x is n, which is less than m, and m is the degree of x. So degree of rx is less than degree of x, and we have we can see that equation is also satisfied, that ax is equal to bx times qx plus rx in this case. And we have this equation that can be easily verified in that case, and we have this ax is equal to this bx times qx plus rx, because here what qx is 0, rx is ax, so ax is x. This equation is satisfied with the condition that degree of rx is less than degree of bx, because degree of rx is same as degree of ax, which is n, and n is less than m, and while m is the degree of x. तो इस केस में आपको कुछ नहीं करना है, if n is less than m. Now we take the other case. Otherwise we have what? This n is greater or equal to m. इस केस में एक्चुअली आपको चेक करना है, इस केस में हम इसको इंडक्शन से करेंगे. What's ax? Degree of ax, it's n. So we explicitly write it. We write ax is the polynomial of degree n. We write it as ax is called a and x power n plus a1x plus a0, where a n is obviously not equal to 0 because its degree is n. इसकी डिग्री n के बराबर है, तो a नॉन जीरो होगा. And we also write bx as, for bx की डिग्री m है, so we start from m power term, so bm x power plus b1x plus bc. Of course, this bm is not equal to 0. So to perform induction, we must have a polynomial of degree less than n. जिस पर हम इंडक्शन अप्लाई करेंगे, क्योंकि आपको प्रूव करना है कि ax के लिए रिजल्ट ट्रू है, ax की डिग्री n है. और आप by induction assumption, we have assumed that's understood. We have assumed that the result is true for all the polynomials of degree less than degree of x. So we'll construct a polynomial of degree less than n, and then we apply the induction hypothesis. How do we do that? We define this polynomial. define. This is always true in this is only true in fx. You cannot do it in general ring, a general polynomial in Rx. Define. So this is the main step here where we are using the field actually. Define the polynomial. Define the, यहाँ तक field का यूज नहीं हुआ है. अब इस step में जो है ना, इस step we are using field actually. Define the polynomial. Define polynomial. Define this polynomial a dash x. It's equal to ax minus. मतलब हमें एक्चुअली एक पॉलिनोमियल कंस्ट्रक्ट करनी है जिसकी डिग्री लेस देन n है. तो फर्स्ट टर्म हम चाहते हैं कि इस पॉलिनोमियल से किसी तरह हट जाए. ये सेकंड टर्म से स्टार्ट हो जाए. तो ax को हम सब्ट्रैक्ट करेंगे उस पॉलिनोमियल से जिसकी फर्स्ट टर्म a and x पावर n है. सो दैट वी कैन कैंसिल आउट दीस टू टर्म्स. ax minus an divided by bm. This can be done because bm is not equal to 0 and we are in the field. X power n minus m. X power n minus m times bx times this polynomial x. So if we expand this one, this is equal to an x power n plus a1x plus a0 minus an divided by bm x power n minus m times bx. Bx is what? It's bm x power m plus b1x plus b0. Now look at this step. Here the first term is a and x power n minus, यहाँ पर देखिए first term क्या है, bm cancel हो जाएगा. X power n minus m times x power m, it will be x power n. It will, so the first term is here a and x power n, तो वो दोनों cancel हो जाएगी. So you will get a polynomial of degree less than. तो इसको हम फर्दर लिख सकते हैं. This is equal to a n x power n. Let's write the second term also here. A n minus 1 x power n minus 1 plus a1x plus a0, then minus you can check the first term will be a and x power n there. Now what's this? What's the second term? Now here the second term is x power m plus 1, x power n minus m, n minus m. So this will be x power n minus 1, x power n minus 1 with the an by bn times bm minus 1. It's like this. It's like this. Plus an by bm, then we have bm minus 1 x power n minus 1 plus the last term. What's the last term here? Last but 1. It's an by bm times b1. Then we have x power n minus m and x, it will be x power n plus 1 minus m. X power n plus 1 minus m. So this is see b previous page. It's an by b. Okay. It's an divided by bm. Then we have bm x power n plus 1 minus m, and then the final term, the constant, not the constant term. This is here. This is here an by bn x power n minus m and b naught plus an by bm. Then we have b naught x power n minus m। तो फर्स्ट टर्म कैंसिल हो रही, तो ये जो ऑप्शन है ना, ये जो टर्म है स्टार्ट हो रही है एक्स पर एन माइनस वन से, यहाँ पर भी एक्स पर एन माइनस वन से स्टार्ट हो रहा है। सो देयरफॉर ए डैश एक्स इट्स अ पॉलिनोमियल इन एफ एक्स, ये एफ एक्स में पॉलिनोमियल है क्योंकि यह फील्ड है, द क्वेश्चन ऑफ टू एलिमेंट्स बिलोंग्स टू एफ, एंड इसकी जो डिग्री है, डिग्री ऑफ ए डैश एक्स इज लेस देन। नाउ यू अप्लाई द इंडेक्शन hypothesis. By induction hypothesis, by induction hypothesis, there is qx rx in fx, qx fx, qx rx in fx, such not we should write q dash x and rx, q dash x, rx such that we have the following. We have this a dash x पर हम इसको अप्लाई करें, a dash x इक्वल टू bx वही है जो है आपके पास, bx times q dash x plus the remainder, where what's rx, it's either 0 or r तो आपको मिल गया ना, आपको डिग्री ऑफ rx is less than डिग्री ऑफ bx। अब सिर्फ एक्चुअली आपको ax के लिए चाहिए, आपको a dash x के लिए मिला है, तो यू कैन सबस्टिट्यूट here a dash x, a dash x को भी यहाँ सबस्टिट्यूट कर सकते हो। तो दिस gives what's a dash x, it's ax minus an by bm, an by bm x power n minus m times bx equal to what, equal to bx times q dash x plus r x। इसको यहाँ ट्रांसफर करिए आप, this gives ax is equal to what, ax equal to this it's an divided by bm x power n minus m, then bx plus this is bx q dash x plus rx. This implies ax is equal to bx is a common factor here, and pull it out. This is what, this is bx times an by bm x power n minus m plus q dash x plus rx, and you can write it as this, ax is equal to bx times qx bx times qx plus rx, where qx is this point, it is in fx again, where what is qx, this is equal to an divided by bm x power n minus m plus q dash x, it belongs to fx, rx तो already था ही fx में, and rx has this properties, rx is 0 or degree of rx is less than degree of bx. So this proves the result for AX also. This proves the result for AX also. इसके बाद uniqueness है, that's simple uniqueness. Okay. So let's suppose that there exists one more pair. There exists one more pair having the same property. So assume that there exists say Q1x and R1x in Fx such that your AX is equal to BX times Q1x plus R1x. Well, what's this R1x? It's either 0 or degree of R1x is less than degree of BX. तो आपको प्रूव करना है ये Q1x है, ये QX के बराबर है, R1x RX के बराबर है। अब क्योंकि AX यहाँ इसके बराबर है और यही AX जो है ना ये BX QX plus RX है, you can equate these two. You can equate these two. We have AX जो है ना आपका this is equal to BX times QX plus RX and that's same as BX times Q1X plus R1X. Okay, so these two are equal. These two are equal. Now, from this you can see this means ये जो है आपके पास AX minus BX QX, it's RX, and AX minus BX Q1X, this is R1X, दोनों की डिग्री है less than degree of BX. That's equal to M actually. These are the polynomials or the polynomials of degrees less than degree of BX, which is M, sorry. तो क्योंकि ये RX के बराबर है, ये R1X के बराबर है, तो दोनों की डिग्री है लेस देन डिग्री ऑफ BX, which is M. अब इनकी जो डिफरेंस होगी, व्हाट अबाउट देयर डिफरेंस, डिफरेंस की डिग्री क्या होगी, व्हाट्स देयर डिफरेंस? इसकी जो डिग्री इसकी जो डिफरेंस होगी दैट्स आल्सो लेस देन, उसकी डिग्री भी होगी लेस देन M, उसकी डिग्री भी क्या होगी लेस देन M. तो डिग्री of the difference, okay, degree of the difference. But what's the difference? That means we can write it like this: degree of is AX minus BX QX minus times AX minus BX Q1X. ये जो डिग्री है क्योंकि दोनों की डिग्री लेस देन M है, that degree of the difference will also be less than M. और ये difference से x they cancel out, so we'll have this degree of, it will be bx times qx minus q1x is less than m. You can check it. This is what ax ये cancel हो जाएगा. This is bx qx, then minus minus plus bx q1x. So it is bx times q1x minus qx actually. मैंने क्या लिखा है? It's bx times q1x minus qx. But what is degree of bx? It is exactly equal to m. It's exactly equal to m, and since we are in integral domain, this means degree of bx plus degree of q1x minus qx. Right. Let me write it like this. Sorry, I will. My claim is that this must be 0. This gives q1x minus qx must be equal to 0. Otherwise, अगर ये 0 नहीं होगा, then what will be the degree? This will be degree of bx plus degree of this. Degree of bx m plus some non-zero integer, some non-negative integer is less than m, which is not possible. So otherwise m would be less than m, a contradiction है. ठीक है, क्योंकि ये जब 0 होगा तो ये प्रोडक्ट इसके साथ 0, ये 0 आ जाएगा. उस केस में इसकी डिग्री कैन ट्रीट that is 0, which is less than m. So this must be 0. This, because if it's non-zero, then degree of this product, ये जो product यहाँ पर आपके पास है, it's greater or equal to m. But on the other hand, it's strictly less than m. It's a contradiction. It's a contradiction. So thus we have this q1x is same as qx. q1x is same as q. Now let's see rx. What's rx? Rx is actually ax minus bx times qx. Okay, but qx is same as q1x. This is ax minus bx q1x, q1x, and ax minus bx q1x is r1x. So this proves both are equal. So that proves the uniqueness part. That proves that proves that this part. Okay. So this is the end of the lecture. End of the lecture. Okay.